Knowledge about IoT. What is IoT? The Internet of Things, IoT, is a network of connected smart devices providing rich data, but it can also be a security nightmare. The IoT brings internet connectivity, data processing and analytics to the world of physical objects. For consumers, this means interacting with the global information network without the intermediary of a keyboard and screen. In enterprise settings, IoT can bring the same efficiencies to manufacturing processes and distribution systems that the Internet has long delivered to knowledge work. Billions of embedded Internet-enabled sensors worldwide provide an incredibly rich set of data that companies can use to improve the safety of their operations. Data from machines can be used to predict whether equipment will break down, giving manufacturers advance warning to prevent long stretches of downtime. Researchers can also use IoT devices to gather data about customer preferences and behavior, though that can have serious implications for privacy and security. How does the IoT work? The first element of an IoT system is the device that gathers data. Broadly speaking, these are Internet-connected devices, so they each have an IP address. They range in complexity from autonomous mobile robots and forklifts that move products around factory floors and warehouses, to simple sensors that monitor the temperature or scan for gas leaks in buildings. They also include personal devices such as fitness trackers that monitor the number of steps individuals take each day. In the next step in the IoT process, collected data is transmitted from the devices to a gathering point. Moving the data can be done wirelessly using a range of technologies or over wired networks. Data can be sent over the Internet to a data center or the cloud. The final step, data processing and analytics, can take place in data centers or the cloud, but sometimes that's not an option. The round-trip time for sending data, processing it, analyzing it and returning instructions, close that valve before the pipes burst, can take too long. In such cases, edge computing can come into play, where a smart edge device can aggregate data, analyze it, and fashion responses if necessary, all within relatively close physical distance, thereby reducing delay. Edge devices also have upstream connectivity for sending data to be further processed and stored. A growing number of edge computing use cases, such as autonomous vehicles that need to make split-second decisions, is accelerating the development of edge technologies that can process and analyze data immediately without going to the cloud. Thank you.